much. In today's presentation, I'm going to demonstrate just how vulnerable our internet identities can be and the way with which they can be stolen. In today's presentation, I'm going to highlight the importance of cybersecurity, pen testing, and personal awareness of such threats. So as we heard today already, we have to breathe, lay down. I can't do that, but I can sit down. So let's take it from there. So before I do so, let me quickly tell a few words about myself. So I'm Cyril. I'm working at Porsche for the past 7 years. I've been working as an iOS system architect for the past 5 years. At Porsche, we are working on this My Porsche application, which essentially orchestrates 31 teams that are contributing to the code base. And with the weekly releases, we are delivering the new features to the vehicles or to the customers. Because our app is talking directly to the vehicle, lots of things could go wrong. Therefore, security is for us very, very important. And roughly 5 years ago, I started myself doing research of what can be done on, for example, jailbroken devices, how those things could be then used for malicious purposes, and how you can do something dodgy if you have the power. Okay, most people actually don't like QA, but I don't really mind it. Like, it's pretty cool. Okay, so what are we gonna do today? So first thing first, we need a target. So our today's target will be Dviba. Dviba is an app specifically developed to practice reverse engineering on iOS. Yeah, with no further ado, let's go into action. Okay, so here you can see is my iPhone 8 Plus running iOS 16 and is jailbroken. Now you can see an overview of Dviba. Dviba is a banking application, so you can see here my shopping list. So yesterday I went to Aldi, then went to Rewe, bought a 911 at Stuttgart, and went for a bakery. So typical week. For our today's focus, we're gonna be focusing on two things. So this one is the first one. So here you can see that I can't send any money from the app because the app has implemented jailbreak detection. And rightfully, the developers don't want people with jailbroken devices to send any money. So that's something in our focus. And second is going to be our share with a friend feature. So if I go there, so this is a typical referral program. And as I see actually when the app is loading the view, I can see that this is not native. So yeah, anyone has a manager here who thinks that developing something non-native is faster? Yeah, I thought so. Well, it's not. So let's just quickly have a look what share with a friend do. So here I can type my email address. It doesn't really matter. Let's do Gmail. Send invite, and it tells me invitation sent to this email address, and that's basically the feature. You can imagine it as a referral via email marketing and so on, or you can refer a friend. Okay, so let's go back to overview. Now let's open up terminal. I'm gonna make it as big as I can. And first thing I have to do actually is to get my hands on Dviba. So what I have to do is to go to my binary dump, and here I'm running Frida server on the device. Frida server essentially serves a couple of useful commands to me. So here I just queried basically all the applications that are running on the phone, and as you can see, Dviba is running as well, so it's one of them. So what I can do now, I actually have to do yeah, this is new to me, so Python now runs in environments. I have to run binary dump, so that actually works within Frida, so that's gonna hook into the memory of the application and dump the binary for me. So now I can do Python. Okay, I need to actually start iProxy. So we're gonna start iProxy on 2 ports. So we're gonna do 2222222 and 66666 to 66666. So those will now be our proxies towards the iPhone. I have to open it up now, and let's see if this is gonna work now. Perfect, and it did. So now we can leave the Python environment, and now we can actually see that we have here Dviba API. So what just happened is that we dumped the memory of the application, because I could also secure copy it from the device, but that would be encrypted by your public key that would be created when you are signing into the device, and that wouldn't be enough for today's demonstration. Okay, so we got IPA. So first thing I have to do is to rename IPA to zip, then unzip Dviba. Then we have a payload here. So let's go there. And let's just directly have a look in Z into Dviba. So this one, unfortunately, I can't make any bigger, but the files, then I can. So in Dviba, we can see that we have code signature. That's not of our interest for today. MOMD also not interesting for today's presentation. Frameworks, that's interesting, because here we can see that we have iOS Security Suite. So iOS Security Suite is one of the SDKs that implements lots of security features, and it's very widely used and pretty much industry standard nowadays. Then we have Realm, Swift, and TrustKit. TrustKit will provide highly likely, like as of now, we see it as a black box. Therefore, all we can say is that TrustKit will highly likely implement SSL pinning within the application. So that's also very useful to us to know. Furthermore, we have some SC info settings bundle. That would be really interesting, but now we actually don't have any feature to work with it now. We have assets, not interesting. Dviba dump binary, that's gonna be interesting. And then we have finally here info plist. Info plist is something that we're gonna also focus on for a little bit. So here, actually, one entry is important for today's demonstration, and please remember it. This is a CF bundle URL schemes. That means that Dviba actually handles a deep link, and that's we're gonna use later on in the presentation. So all I have to know now that Dviba will handle this deep link and also this one. Okay, and then we have here share with a friend HTML. So that actually looks awful a lot like the feature that we saw here in share with a friend. And this highly likely, we can imagine, is the view that's being loaded offline into the feature. So what we're gonna be interested in here, we don't really care about any style, but here we have a JavaScript. That's something we can look at. And then we have some HTML, which we also don't mind that much. This is pretty simple, as you can see in the application. So let us quickly have a look at the JavaScript. So here we have 4 functions. We have inject email, we have set email, get token, and update token. So set email essentially takes something from the input and then sets it here, as you can see, and then sets a class on CSS. Similarly, inject email. Now we can't actually see how it's called. Set email is called somewhere from the body. If we have a look, then we have it here. So that would be a primary button. So that's the send invitation button. And yeah, that's all we need to know for those 2 functions. But now let's have a look at get token and update token. So this is actually really interesting, because here we can see get token, and here we have data with an action, and action is called get token. Furthermore, we see window WebKit. We see also WebKit message handlers and some message handler for iOS, which is highly likely, or at this point we can say with certainty that this was actually developed for inter-process communication between the WK web view and the main application process. So WK Web View is the component that basically displays the view, and it's really, really secure. By default, it runs in a separate process, so that it runs in isolation from your main application. And the way how it can talk to your main app is via the inter-process communication, or so-called IPC. That basically is a message broker. You can send messages from one process to another, and you can subscribe for topics and then do some handling. Furthermore, here on line 277, we see that here we have post message with the action, so that's quite clear, and then we have here update token with the data. So as far as I can imagine now, so this one will highly likely store the data, probably the token on the HTML to do some later on networking where you would essentially identify the user. Okay, so here is actually something also interesting, and we see want to do at email plus input validation. Okay, that's definitely something we can try, and it uses inner HTML. So if you think that this is something non-standard, then let me just show you best way to inject HTML using JavaScript. And here is the accepted answer, which is inner HTML. And there is nothing about input validation. And we, iOS developers, don't necessarily have to know all the implications of implementing something in a web view. Okay, so let's have a look at some examples, shall we? So what could we do? So first thing that could pop to my mind is to just insert simple alert and display hello world or hello there. Well, in this case, that wouldn't work because we have already loaded HTML, and this isn't any script, so that would just display it back to us as a plain string. So not really interesting. But what if we would have a script that we would inject, and we would place the alert within the script? So let's find out. Let's see what it's gonna do. So let me just paste the script. So I will copy the script, paste it here. Now if I press send, nothing happened. Yeah, well, why nothing happened? First of all, that's a bit disappointing, but yeah, I wouldn't expect anything else. So the thing is that the web view is already loaded. So we are actually injecting the script into the web view, into the JavaScript. The script is there, but nothing is calling our script. So that's the problem. Okay, so what if we would basically take an image? We would inject an image to the HTML, and the image has onload function. And in the onload function, we could basically trigger the script that we would want to. So let's try that, because this feels like might be the way. So let me just load the view again. Let's have a look at exploit 2. Copy and paste it in. And we got hello there. Awesome. So we actually achieved a very simple script injection into the web view. So this is really something. So I think we are onto something. So let's have a look. So we now have this get token, set email, and update token functions. So essentially, what I would like to do in the exploit 3 is to load the remote image, set a style to not to display the image, and then on load I would call get token function, which would trigger inter-process communication from the web view to the main process of the app, which would get the token from the main app, and then I would override the update token function with the same functions signature in JavaScript, and I would then display the data in the alert. So let's find out if that's gonna work, because that would be really awesome. So if I go back, exploit 3, I will copy it. No, come back. Okay, paste, send, and we got the token. So this is really vulnerable now. So we can think of some attack scenarios which we could then develop with already this easy injection. But still, right now, as far as I can imagine, I would have to somewhere store this script. A friend of mine would hand me the phone, I would inject the script there, then I would have to screenshot the token expires in the next 20 minutes, not great. But it's still something really vulnerable. This shouldn't happen at all. Okay, so is there something more we could do? And the question obviously is yes. So what if we call the remote image, we don't display it again, and on load we would get the token, we would update the token, we would override the update token function again, then we would basically get another element from the HTML where we would yet again inject another image, which would be served from our own server, where we would be able to then pass in the data. So first thing that could come to the mind would be, okay, why can't I just do a network request call and send the token to my server? So WK WebView is really, really secure, and it implements all the modern browsers features. So I would be stopped immediately with cross-site scripting and same request origin policy. So that would block me. That was the first thing I tried. Then after a couple of hours, I thought, okay, this must work, and I will, I can put my hands on the token, so I just need a way to transfer it. And the way how to do it is to basically double inject image, which would then pass in the token. So what I didn't tell you yet is that I also have my own server. So that's like Dviba sniffing. So this essentially serves the image. So if I go a.jpg, then this is gonna pop in. And okay, let's give it a try. So if I bring back the phone, now let's have a look at exploit 4. Copy. Paste. Send. Then we got the image here, but most importantly, we got the token here. So now we are actually able to get the token on our server, and this is already something really, really vulnerable. So now I would be able to figure out from the binary like all the APIs that might have, and start like scraping the data for this token. I would be able to maybe rob, get money of the account and so on and so forth, whatever you can think of. However, this still is a simple attack vector where you have just one-to-one relation with the device and the user. So yeah, we could target one single person. But let's talk remote. Like we saw in the info plist that there was the deep link, right? And that's really, really interesting. So now we have the deep link. So this is the URL that the app would handle. And we have share and name and variable. Now I don't have enough time to prove it to you that I was able to figure it out. But if I go actually to the dump binary, here is the payload. So here is show package contents. Here is our Dviba binary. Now we have to dump it to my favorite Hopper disassembler. This is Mac OS ARC64 because I'm running it on iPhone 8 Plus. Yeah, I'm still not paying for Hopper. Okay, and now we got the binary here. So anyone from the audience could tell me how deep links are handled in SwiftUI? I think it's on URL, can open, something like that, on can. So can open URL, that's definitely something. But this is the Objective-C API. So I'm just trying to figure it out how it's handled. So here is can open URL. So we can have a look at the reference in the binary and where it's called. So this is basically opening a URL. I wanted to show you the one in Swift, and I think it's on can on URL. Sorry? On open. Yeah, that's the one. So it's this one, and this is the symbol that basically goes to the SwiftUI. And now I can have a look where it's called. And this is basically where the function is implemented. And here I would be able to hook into the apps runtime and read from the registers what are the parameters of of the call of the deep link. Something similar you will see in a bit. So this is a proof that this is vulnerable, or that the app actually handles the deep links. So now, what about the variable? Like, you see that there is a variable. So what if we would inject the script to the variable? This is the answer. Like, this is pre-GPT era when it was developed, and this is basically escape character JavaScript injected into the like URL encoded JavaScript injected as the name. And this took me like 5 hours to figure it out, all the escaping characters. But essentially, now we have a deep link that should trigger something in the app, and we are parsing in our maliciously developed JavaScript that should exploit the share with a friend feature. So let's try it out. So here, if I go back, let me just go to the account tab. And now if I open Nodes and have a look at my final deep link, open it up, then it triggered the feature, and also it sent me the token to my server. So this is super amazing, right? So now we have a link that we can send, and we can do a massive campaign and send it to all users of Dviba and wait for them to click on it. So let's just do a simple demonstration. So my mate Arnold, hi mate, this is awesome. And get €5 for free, because everyone loves free money. Click here. So what I have to do essentially is to just like tap here, link, add link. And now let me just grab it from the presentation. And now here, I will just inject the link, send it to Arnold. And just so happened that I have my second phone, and this is Arnold's. And because we are quite a good mates. Now, if I open the email and click on the email, then it opened up the Dviba. But most importantly, it sends us the token of Arnold from my non-jailbroken iOS 26 device. So now we actually stole Arnold's identity, and this is amazing. But I'm not finished yet, so wait for it. So I would be able now to like run all the scripts server side, like use the token to access all the server's APIs of Dviba, scrape this money, send it to my server. But like, why would I do it backend side? Like, first of all, it could be also that the Dviba implements some sort of like deeper security mechanisms like device integrity check. So the server would check if the device is legit, and mine isn't. So let's actually do some proper debugging and reverse engineering. So here what I'm going to do is I'm going to SSH to my device. I'm using the 2222 port. So I'm logged in as a root, so this is the device. And second here, I'm going to start LLDB. Here I'm going to actually have to start the debug server on the localhost on the 6s. And now in LLDB, I can do platform, select remote iOS, and then process connect on the 6s. And that should hook me into the runtime of Dviba. So right now, we are hooked into the runtime of the application. So I can actually do image list. So those are all the SDKs that are loaded into the Dviba's runtime. You can see that there are 544 of dynamic SDKs. Those are mostly the private libraries. If you remember the presentation from like 2019 from Apple about dynamic linking, so they tell you you should use a maximum of half of a dozen SDKs, while they themselves are using 544. Yeah. Here we can see also the private ones. So iOS security suite is there, and so on. So this is the runtime of Dviba. What I'm, however, interested in now is to basically what I need to do is to inject the token into the keychain. So I can write an expression So expression, we're gonna use language Swift. You can write expressions in LLDB. Okay, that's not it. Nah. Okay, so what did it do? Okay, so we didn't kill the app, so that's good. So let's try it again. So let's do expression, and I think I missed the double. Yeah. So this is essentially like the keychain injection. So here is the token of R nodes. And you might rightfully ask me again, okay, how did I figure it out? How the app is handling keychain? And answer is, I have probably 4 answers. So I could just trace the app and I could see what the app is doing with keychain. Keychain in the end is just an SQLite database, which has some higher permissions. And on iOS device, when you have it unlocked, you can fully trace it and you can observe all the possible parameters that the keychain entries would have. Second, which I have at hand now, would be to also have a look here. And keychain is Objective-C API, so it would have the symbols in, and I can see here already KSEC attribute account. I can then trace it to the point where it's used. This would take me rather longer time, but I would be also available. I would be also able to figure it out from the binary and the runtime. Okay, cool. Now if I press enter. Come on. Yeah, okay, I think I know. Okay, so what happened, now if I continue the process execution, then I'm back in the application's runtime. It actually succeeded because you can see it here. So what I can do is now to run process detach. That will kill my debug server here. And if I go back to the app, so nothing happened here, but as every sane developer, I'm caching the token, or Dweba is caching the token. And if I restart the app, then you can see that we have a different account list already. So here we have Apple, Protein Shakes, Gym, Under Armour, Porsche Stuttgart. So Arnold is also driving 911 now. And if I press here, then I'm in an account of Hardcore Killer. So not sure if that's a good idea or not, but we are already in this jam, so let's continue. So next one would be to basically steal his money, right? Here I'm facing the jailbroken device detected. So let's have a look at the binary again. And here, let's search for is jailbroken. And here we have a hit. And this is the function. This is an Objective-C function, actually. So this tells us already a lot. And we can do a few things with it. So first one would be that we have to actually hook into the runtime again. So I'm going to start the debug server again. Here I'm going to, I have to kill LLDB. And I have to do process connect again. Now I have to get the address space layout randomization offset, because every single time a binary loads into memory, it loads into a different address space. That's a security feature of kernel and all modern operating systems, actually. So now I have to actually resolve the address space layout randomization. So image list -o-f on Dweba will give me the offset. So that's the offset. And now I can calculate the address in memory. So I will take the offset, and I'm going to add there the function of the is jailbroken. So I'm going to calculate those two addresses together. Now I'm going to set a breakpoint. So I'm going to do breakpoint set on address. We got a hit, so that means that we actually are setting a breakpoint on a valid address. Now if we continue, and if I go back, then if I tap send, then I'm here in the debugger. So now I can disassemble the thread where I just landed. And here you can see that we have the typical jailbreak detection thread. So here is CDR check. Here are a couple of other checks that are not so interesting for now, but I can see obviously that as soon as this is executed, then the banner would be displayed. So what I can do is now to step through, let the stack initialize a little bit, and once I've done that, I can do thread return 0 and press continue. And now you can see that I overrode the function. It no longer shows me the device is jailbroken, and I can use the feature. So essentially, by hooking into the runtime, I was able to bypass the check, and I was able to bypass the whole jailbreak detection check, and was able to get into the view. I'm already in the red time, but this will take me just 1 or 2 more. Or let's send 1,000. Okay, and we did it. So we actually robbed Arnold for $1,000 or euro. So that's awesome. Like, I'm gonna get killed, but it's fine. Okay, now I can continue. And now you can see that I'm facing this again because this is triggered on display or on view. View did load, something like that. Okay, I can do one more thing. So what I could do also is to write another expression. So I have to do process interrupt. I can write an expression. No, actually, I can override the function with the runtime API of Objective-C. So I can set up a function which we will call always false. Always false. So we're gonna set up always false function that's basically injected into the runtime. We can then call it. Always false gives us back nil, aka false. We need to find its address. So always false. So this is the address of the function, and now I can write Objective-C expression, which basically will do for me a runtime swizzling. So this will use the Objective-C API. Here we have method set implementation, class get class, jailbroken class, everything we were able to figure it out from the binary. We got a hit. So now if I continue the process execution, I press send, I'm no longer facing the banner. That was so annoying. So now, like, you can imagine that now I would go to Darknet, I would search for like Dviba leaked database where I would get all the email addresses of all clients of Dviba. I would like send to all of them some nice campaign that everybody would be able to get extra 10 euro on their account. Everybody would click it, I would get the tokens, and I would then rob them for all their money. How evil is that? Cool. Yeah. That was it from the presentation. So here is a quick summary of what happened. So we did binary dump. We had to do it because the binary itself is encrypted. So that's what I had to do on my jailbroken device. We found an exploit. We were able to exploit the share feature. We were able to, from the binary, figure it out how the deep link works, and we were able to inject the malicious code into the deep link. We hooked into the runtime in Objective-C. We bypassed jailbreak detection. We robbed Arnold for $1,000, and I'm gonna get hunted. Super cool. So the first question would be, can this be done in a secure way? And the answer is obviously yes. So every single pen tester would discover this vulnerability. But we all know that sometimes we ship features under stress. Some things might be missed. And I personally believe that such potential vulnerabilities are there live in the App Store. And when you see the hybrid apps, then I have no doubt that there are some similar vulnerabilities, highly likely not exploitable like this one. So this was like an academic example, right? So it all played out. But if you think this was easy to do, that took me like 3 months to develop because I had no idea if that's gonna work or not. Here's a couple of examples that I accomplished. So binary dump we saw today, runtime manipulation we saw. Extraction in memory secrets. So if you are having loaded things in memory, you get the phone, you hook hooked it up, debug server, login into the memory, and then you are able also to extract things in memory in plain text. So storing passwords in memory, not a good idea. Face ID full bypass also, if wrongly implemented, however. So if you don't back up your keychain with a real value in the keychain, then this can be also bypassed by just hooking into the function, same as you saw today with the, or similar as you saw today with the jailbreak detection. Crypto algorithms, like you can extract any kind of common crypto because it's in Objective-C, so you can hook into the runtime, you can observe them. There are also open source scripts that would be tracing those APIs for you, and you can then see what the app is actually using. Keychain dump, that's a simple SQL database. SSL pinning full bypass, we saw it today, but that would be another presentation where I would be able to also break the SSL pinning just by injecting it into runtime, for example, or injecting some things into runtime, or swizzling the library that was the Trustkit library that was loaded in. So I'm sweaty. And that was it. Yeah, thank you very much for sticking to it.